morning, students. My name is N.V. Krishna Rao, Assistant Professor in CEC Department. I'm handling the comparison. So, in the previous class, we discussed some bottom-up parsing methods. Now, we'll discuss the Operator-Precedence parsing method. So, this is Operator-Precedence parsing method is one of the bottom-up parsing method. So, that we'll discuss today class. In the last class, we have discussed the shift reduce parsing method and some drawbacks in that shift reduce parsing. To overcome the shift reduce parsing method, we will use operator precedence parser or LR parsers. This operator precedence parsers is simple but applicable only on small class of grammars. Where LR parsers we can apply for more number of grammars. Here, in this operator precedence parser, we use the operator grammar. What is the operator grammar? So here, the operator grammar simply says that no two variables are adjacent. They must be operator between two operands. So here, the operator is small but an important class of grammars. So it is an important class of grammars. We may have an efficient operator precedence parser, a shift. It uses the shift reduce parsing method for an operator grammar. So here, in an operator grammar, there should not be any epsilons on the right side. There should not be any epsilons on the right side. And there should not be two adjacent non-terminals. There should not be two adjacent non-terminals. And there must be a terminal between two non-terminals. Then the grammar is said to be operator grammar. So, this operator precedence parser uses the concept of shift reduce parsing method but applicable on the operator grammar. But it is applicable on operator grammar. So, this operator grammar is defined as no epsilons on the right side and no two adjacent non-terminals. There must be a terminal between two non-terminals. Here, in this example, there are two adjacent non-terminals. So, simply it is not operator grammar. Here, it seems there are three non-terminals. Simply we say it is not operator grammar. But if we consider this one, terminal, terminal, terminal and a terminal. So, simply we consider this as operator grammar. No epsilon production on the right side of a production in a grammar and there must be no two adjacent non-terminals. Right? Here, in this operator precedence, we define three relations. Higher precedence, lower precedence, same precedence. Right? B has higher precedence than A. Higher precedence. B has higher precedence than A. Then B has same precedence as A. B has same precedence as A. B has lower precedence than A. So here B has lower precedence than A. So we use the three operator precedence, right? symbols. Here relations, that three relations have of higher precedence relation, same precedence relation, lower precedence relation. Right? A less than B, A equal to B, A greater than B. Right? So here B has higher precedence than A. AB is same. B has less precedence than A. Here, the determination of correct precedence relation between terminals based on the traditional notation of the associativity and precedence of the operators. So here we consider normal, associative and precedence of the operators. Here, this operator precedence parsing method has a problem with unary minus. It is unable to determine a unary minus or binary minus. Here, the intention of precedence relation is to find the handle of a right sentential form. Right? So, to find the handle of a right sentential form. So, we insert these relational operators less than, greater than, equal between all the terminals in the input string. Right? We will insert these relations, precedence relations in between all the terminals, in between all the terminals in the input symbol. So here we used to find a handle in the input string, right? Right, for the right sentential form. So here it will help as left hand. So here this one appear as interior handle. Here this is as right hand, right? Left hand and right hand, right? Here in our input string, this is our input string. We insert the precedence relation between the pair of terminals. So here in this input string, we'll insert all the precedence relations between the operator. So for this grammar, E equal to E plus E, E minus E, E into E, E slash E, E power E, parenthesis E, unary E, ID. So here this is a grammar for the operators. For this one, we are considering only partial operator precedence table for this grammar. Later, we'll see the complete table of operator precedence relation. But here we are considering only partial operator precedence table. This one called as, this table is called as operator precedence table, right? Operator precedence table. It will represent the relations, precedence relations between the terminal symbols. So here ID. Remember the first thing, ID has higher precedence. ID has higher precedence. End mark has least precedence. Right? Then multiplication has higher precedence than addition. Multiplication has higher precedence than addition. So this one is all higher. This one is ID is here. Here it is ID. It is the least. It is least. Then plus. ID greater than plus. Plus and plus. So we consider the associative property of the plus and plus. So we consider higher. The first one is executed first. So higher precedence. Then multiplication plus, always high. Multiplication is higher precedence. ID and multiplication, ID only. Plus and multiplication, multiplication only. Multiplication. Then the first multiplication, left associative, will be executed first. So higher precedence. Then the input string id plus id into id with the precedence relations inserted will be as in this form. So dollar sign less than id, id is greater than plus is less precedence than id, is higher precedence than multiplication, multiplication is less precedence than id, then id is high precedence than the dollar sign. So these from this operator precedence table, the relations, the precedence relations are inserted between the terminals of the input string. Between the terminals of the input string. Then scan the string from left hand to until the first first higher precedence is encountered. Right? Scan the string from left hand until the first higher precedence is encountered. So scan back and find if over any equal precedence until less precedence. And so whatever the symbols that we found between the higher and lower precedence relations will be considered as the handle. So here the handle means everything left of the first higher precedence and right of the less precedence operators. Right? So here this is the first executed. Right? So here we are considering evaluated id as e. Then then we consider this one, right? Id as e. Then we consider id once again. E gives id gives e. Then multiplication is handled. Multiplication is evaluated. Then plus is evaluated. Then plus is evaluated. Right? Then plus is evaluated. Then the input is completed. Finally, we evaluated the input string. So here we'll insert the precedence relations between all the terminals of the input string. Then we will consider the left of the first higher precedence and right of the less precedence is considered as the handle and in the right sentential form. So we will evaluate them so that finally we pass the input string by using the operator precedence passing method. So here this is a first, then this id is evaluated, then this id is evaluated, then multiplication is evaluated, then addition is evaluated. So the order by which we are evaluating the input string. So here using this precedence relations we are finding the handle and we pass the handle. Now so the input string is $, end mark is used as a dollar sign and initial stack symbol is dollar sign. A table holds the precedence relations between the certain terminals. So initially the algorithm, we'll discuss the operator precedence passing algorithm. Initially the input string end with a dollar sign and we use the initial stack with dollar sign. Then we holds a table precedence relations between certain terminals. Set P point to the first symbol of the input string and repeat forever. Dollar is on the top of the stack, P points to dollars, then return. Means the parsing is completed. Otherwise, let A be the A be the topmost terminal symbol on the stack. Topmost terminal symbol on the stack. And let B be the symbol pointed by P in the input. A is the stack symbol, A is the stack symbol, B is the input symbol. Right? If A less than B or A equal B, perform shift operation. Right? The stack symbol is less precedence or equal to the input symbol, then perform the shift operation. Right? Perform the shift operation. Simply push B onto the stack and advanced P point to the next input symbol. Else if the stack symbol, else if the stack symbol is higher precedence than B, stack symbol is higher precedence than B, then perform the direction. Perform the direction. What is? Pop the stack symbols until that. Pop the stack symbols until that the top of the stack is less precedence than the input symbol. Right? So this considered as the Z action. So we will perform shift and reduce as same the concept of the shift reduce parsing method, and we using this relation precedence relations we will overcome the drawback in the simple shift reduce parsing method. Right? So this is a algorithm for the operator precedence parsing algorithm. Right? Now initially stack with dollar sign and input ends with dollar sign. Stack with dollar sign and input ends with a dollar sign. Then what is the relation? Stack is less than input. Simply perform shift. Then ID and plus. ID and plus. ID is stack symbol is higher precedence. Then perform direction. Then perform direction. Right? Then here dollar sign less than plus. So perform shift action. Then plus is less than ID. So perform shift action. Then ID is greater than dollar. ID is greater than multiplication. So perform reduction, reduce ID. Since ID is higher distance than multiplication. Then plus and multiplication. Plus and multiplication. So plus is less precedence than multiplication. Simply perform shift action. Then multiplication less than ID. So simply perform shift action. Then ID greater than dollar sign. ID greater than dollar sign. ID greater than dollar sign. Simply ID greater than dollar sign. Reduce will be performed for equal to ID. Now multiplication dollar. Multiplication is a higher precedence. Right? Perform multiplication operation. Then addition is higher precedence than dollar sign. So simply perform addition operation. Since input is empty with dollar sign, stack is empty with dollar sign, the string is said to be accepted. So here we are passing the input string using the operator-precedence parsing method, using the concepts of shift, reduce and accept a help. Here these are all the rules and regulations for finding the precedence relations between all the different type of time. Here, omega 1 is higher, O1 is higher precedence than 2. So we use this relation or this relation. 1 O1 has higher precedence than O2. Then operator 1 and operator 2 have equal precedence and left associativity. 1 and 2 equal precedence. Then left associative. Then we have to use which is the first one to be executed first. If two operators with same equal precedence, then if it is a left associative, then this higher precedence symbol we have to consider. If it is right associative, this less precedence operator to be considered. Then for all operators O represent all the operators. Always the O less than ID, ID greater than operators, ID is a higher precedence, then balance is, right? This left balance is a higher precedence and this operator is a higher precedence left. Which is first come will be the higher precedence, right? So here this one less precedence than right balance is operator as higher precedence than the right balance is. Right balance is as higher precedence than operator. Then operator higher precedence than dollar sign. The dollar sign less precedence than operator. Right? So these are the relation between ID and operator and balances and dollar sign. Right? Here both operators same sign. Dollar sign always is less than right balances. ID is greater than right balances. Right balance is greater than dollar sign. Right? Here right balance is less than and left balance is less than another left balance is dollar sign less than ID. ID greater than dollar sign. Right balance is greater than right balances. Left balance is less than left balances. But right balance is greater than right balances. And left balance is less than ID. So using this all relations, we construct the operator-precedence table. This is the operator-precedence table between all the operators, identifiers and balances dollar sign. Right? So always ID has the higher precedence, dollar sign has the least precedence. Then we use the power, division, multiplication, plus or minus with the respect to operator precedence relations. So if we consider ID always has higher precedence. Here ID I precedence, dollar sign less precedence, dollar sign less precedence, right? Then this one as least precedence and this one as least precedence. Just now we discussed between the relation between operators, right? So here this is a less. So here we are considering and same thing here. When you consider these left hand balances, they are equal. Okay. From these discussions, we are filling this operator precedence relationships, right? Then similarly, we are exponent, division, multiplication, minus and plus operators. Simply we insert the precedence relations for this X. Here power as high precedence. When is power and power? right balances, right? So here this is right associativity. Here for these variables, left associativity, left associativity. But here this is right associativity. Then division. Here just we are inserting the relationships between all these operators. The main drawback is handling the unary minus. It is unable to find it is a unary minus or binary minus. Operator-Precedence parsing cannot handle the unary minus when we have also the binary minus in our grammar. When we have both unary and binary in the same grammar, then it is unable to find the correct one. The best approach to solve this problem, let the lexical analyzer handle this problem. While it is lexical analyzer constructing the tokens, then it will group the binary minus with binary with two operands, a unary minus with one operand, so that this problem will be resolved. Right? Operator less than unary minus for any operator. Unary minus is a higher precedence than operators with unary minus higher precedence than operators. Unary minus less lower precedence than operators. Here, another one we use is operator-precedence function. Listen here, if we have the operator-precedence table, there are so many relations. The table will be larger. To simplify the large operator-precedence table to smaller one, and if we have the symbols like greater than, less than symbols in the table to perform the operations, either shift or reduce will be get headache. To overcome that, we use operator-precedence function such that by using two functions f and g, we will map these relations to integers, so that a simple integer comparison, by using a simple integer comparison, we will perform the shift reduce operations of the operator-precedence table, right? Operator-precedence parsing method. So having these symbols in the large table, performing the operator-precedence parsing is a headache one. So we will convert the operator-precedence table into the smaller size, and it will map with the integer values such that we can compare the stack uh, and stack symbol and input symbol relations with simple integer comparison, so that we can perform the shift reduce parsing method with the in this operator-precedence parsing method. Okay. Now we'll discuss how to map the operator-precedence table to the integer valued operator-precedence table, so that we can perform the shift reduce method in this operator-precedence parsing method. Right? Here, this is the table. ID plus ID multiplication $sign. This is a first table that we discussed, so that we to understand this conversion. So I'm taking the symbol one, right? Here in this table, we consider this rows as f function, this column as g function. We represent a simple graph where each node represents one operator, and we draw the arcs. We draw the arrows. This arrow will be drawn from higher precedence to lower precedence operator. Higher precedence operator to lower precedence operator. Right? So we draw the arrows between all these nodes such that we'll find the largest path from that particular operator. That largest size will be the integer representation in the below table. Right? So here FID high precedence than G plus G multiplication and dollar sign. So here writing GID, FID, F multiplication, G multiplication, G plus, F dollar, G dollar. So we have represented all the terminal symbols in the nodes. Then we have to draw. Then what is our next step? We have to draw the arrows from the operator-precedence relations in the table. Then FID as greater than G plus. FID to G plus. FID to G multiplication. Then FID to G dollar. Similarly, GID to F multiplication, F plus and F dollar. Right? Right? Then plus sign. F plus. F plus less than GID. F plus is less than GID. Right? Then F plus greater than G plus. F plus is greater than G plus. F plus greater than G plus. Then F plus less than G multiplication. Right? Then F plus greater than G dollar sign. Right? G dollar sign. Then F multiplication less than ID, less than GID. Right? Then F multiplication greater than G plus. F multiplication greater than G plus. F multiplication greater than G multiplication. F multiplication greater than G multiplication. Higher precedence operator to low precedence operator. We draw the arrow. Right? Then dollar sign as least precedence. So it will have the all arrows into the node. Now we have drawn our arrows. We have to find the length of largest path from the particular node. Now ID. From GID there are so many paths. But what is we required? The size of the largest path. GID. This path as 1. 1, 2, 3. 1, 2. 1, 2, 3. 1, 2. 1, 2, 3, 4, 5. If we consider GID to F multiplication 1, 2, 3, 4, then 5, then 6. 6 nodes, length 5. So 5. Then if we consider ID 1, 2, 3, 4. So the maximum length of the path that is possible from FID is only 4. If we consider dollar signs, simply zeros. Then we check F multiplication. F multiplication 1, 2, 3 and 4. Right? So it is 4. G multiplication 1, 2, 3. So it is 3 only. So from the operator-precedence relations table to operator-precedence function table we are constructing. So by considering two functions f and g, we are converting the given table relationship table to integer value table. So we can perform the integer comparison easily, and we reduce the size such that we can perform shift reduce parsing in the operator precedence parsing method, right? So here the disadvantage, it cannot handle the unit minus. It is applicable only the small class of the grammars. It is difficult to decide which language is recognized by the grammar. So these are the disadvantages of this operator precedence parsing method. Advantages: it is simple, it is powerful enough for expressions in the programming language, right? So these are the advantages and disadvantages of the operator precedence parsing method of the bottom up parsing methods. So for today, I am closing this class, and in next class we will continue the remaining topics. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.